Hey guys, welcome to this video. So in this video we are going to see how to tune any SQL statement with a SQL profile. So there are multiple ways to tune any SQL statements. We have hints option, we have SQL profile, we have SQL baseline, we have SQL patch. Okay, so all these are different tools provided by Oracle to control or influence the optimize's execution plan. Okay, so tuning a SQL statement is nothing but, it is not a rocket science. Okay, so it is just controlling or influencing optimizer's execution plan. That's it. Okay, so every SQL that are executing on the database requires some optimization, right? So that optimization is decided by a tool or algorithm called optimizer, right? So optimizer is the brain of Oracle database, right? So it has the intelligence to decide the fastest possible access paths that can be used to fetch the data, right? So performance means, to be simple, any task which is performed within a given amount of time, right? So that is called as performance, right? So we measure the time as the performance. So here these are similar ways of controlling the plan, but in a different manner. That's it. Okay, so if you see, first option is hints. Okay, so hints are a direct way to control the optimizer's execution plan manually. Okay, so if I get control to any select queries from the application side, only when I get control I can use the hints, right? Otherwise I cannot use the hints on application executed SQL, right? So if the application is executing the SQL, I don't have access to the application, right? So since I'm a DBA, so I would not be able to control the plan. But if I'm executing the query manually, or if the application user is executing manually, so you can tell him to use the particular hint to choose the available access path. Second one is SQL profile. Okay, so SQL profile also is kind of a set of hints. Okay, so it is a collection of hints which will direct the optimizer's execution plan. So it will just provide some recommendations to the optimizer that you can use these hints, and this plan is better compared to the other plan. So optimizer will just see if there is a SQL profile already created for this particular SQL or not, SQL ID or not. Then optimizer will check if that plan is good. If that plan is good, it will use that SQL profile. Okay, so it is kind of profiling all the execution plan, right? So it's not all the execution plan, but multiple execution plans will be there. But if there is a better plan, then that better plan will be having a SQL profile. Okay, either we can manually create the SQL profile, or we can run the SQL tuning advisor report to get the procedure for creating the SQL profile. Okay, so to be simple, SQL profile will not force the optimizer to choose a better execution plan, but it is optimizer's decision. Okay, so the majority of the control will be on the optimizer side. Okay, and optimizer has a choice of using the SQL profile. But here, if we use the hints in the query, optimizer has to use the plan which is the hints that we are using in the SQL. Okay, optimizer has no other option. This is kind of forcing the execution plan, okay, in a manual way. But SQL profile, it is kind of an optional, and optimizer may or may not choose the SQL profile. If you come to SQL baseline is kind of fixing or forcing the plan. Okay, so it's kind of there are multiple phases in SQL baseline. Okay, so we don't discuss much deeper on SQL baseline in this session. I will give you another session. So SQL baseline is kind of forcing the plan. SQL profile is not forcing the plan. It is just giving direction to the optimizer. That's it. Okay. So it also has some outline hints. It will also provide some outline hints. So based on those outline hints, optimizer will decide the best execution plan, either SQL profile or SQL baseline. And SQL patch is it is also kind of a tool, okay, which can be used to inject the hint. Okay, so here I mentioned that whenever we are using any hints on the query, we only can manually use the hints on the query. We cannot directly use it on the application SQL. So this is a challenge, right? Because none of the DBA will be getting access to the application SQLs. They just monitor the SQLs and they just recommend the good plans, and they just check the performance of the SQL, but they don't have direct control to the SQL unless until if someone is testing on QA or staging. So those people will say that there is some performance issue. They will give the query itself, so we can test on staging, but in production we will not be able to do the same thing, right? So we cannot run a million rows query in a production system for testing, right? So in those cases, if we after we do our analysis, and if we come to a conclusion that optimizer is not choosing the good execution plan, then instead of using the hints manually, we can just inject the hint on the application SQL. Okay, so if I just create a SQL patch for a particular SQL ID saying that you need to use the hint for this particular SQL or SQL ID, optimizer will just see if any of these tools are being used for any of the SQL ID. If any of these tools are used, if SQL patch is used, then optimizer will see what is the hint that is specified inside the SQL patch. Then it will directly use the hint and go for the good execution plan. Okay, so these are the different ways of controlling the plan. So we can just create a test case so that you will understand what exactly that is happening. So we are just going to insert millions of rows in. We are creating two tables, customers, orders, and we are inserting multiple data inside the customers and the orders table. Okay, and we are just going to join both of these table when we are querying the data. Just create the index on status and orders customers column. Then we are just going to gather the statistics. So this is where the actual issue that we are going to simulate. Okay, so here in order, right, so on orders table we are not going to collect the histograms. Okay, so histograms are very important for skewed data. So if you see here, the second part of this procedure is having some insert loop, which is inserting some skewness of data, which skew means you can take an example of just take an example. There is a table, and this table has a column called gender, and this gender has two values, one is male, another one is female. Okay, just imagine that almost 99% of the data that is stored on the column gender is male, and 1% is female, right? So here there is an imbalance of data, right? So whenever we are fetching the female data, so optimizer may get confused, and it does not have the actual data knowledge, right? So it just works based on some predetermined algorithmic formulas and the CPU IO costs, right? So optimizer will misestimate the cardinality, and it will choose the wrong, it will pick the wrong execution plan. Okay, so that is called as skewness. Data is not balanced, right? Because the majority of the data that is stored on the gender column is male, so optimizer will get biased, or it may get favored, it may favor male data. Okay, so similarly here, if you see, when I less than this particular amount, then when I less than this particular amount, then open, else closed. So now if you just query the amount of data, let us just see the distribution of data. Just check the status column. So here if you see, almost majority of the data that is stored is open. So only 1% of the data that is stored is closed under status column, right? So this, and also we purposefully didn't create any histograms, right? We just we are just going to gather the we are not going to gather the histogram statistics for the orders table. Okay, okay, so now no histogram on status column on the orders table. So Oracle will assume an uniform distribution. So but here there is no uniform distribution, as we already seen. There is an imbalance in the data, right? So it is completely misleading for the optimizer. Okay, so now when we execute this query, what we are doing, we are just selecting the region and the count of star from orders, and also we are joining the customers table, and we are specifically using status in the where clause, where status is equal to closed. So this is when optimizer will get confused. Okay, so here optimizer will get confused about picking the index plan or full table scan. Okay, actually optimizer should choose the index plan, okay, but it will go for a full table scan. Only 13 rows are queried, okay, out of millions of rows, but optimizer has gone for a table access full, right? So always there is a rule of thumb that in Oracle, if minority of the data is queried from majority of the data, then index will be used. Okay, and if majority of the data is queried, then full table scan will be used. Okay, there are some exceptions like size of the table. So if the table size is very big, okay, this is when this scenario will be happening. But if the table size is small, then what happen is even the majority of the data will be minority, right? So here you can take this many amount of data as big. Okay, so here small is 1000. Okay, so if you just query majority of the data from only 1000 rows, then just imagine, or I will give you more clear example. So we cannot say that 1000 is big or small, but let's say there are 10 rows. Okay, so 10 rows is if you, even in a test database, querying 10 rows will be very fast. Okay, so now you will be able to understand. Querying majority of the rows from this small table does not need an index, right? Anyway, there are only 10 rows, then why using why we need to use an index? Because always remember that using an index needs additional IO overhead. Why? Because Oracle needs to traverse through the index nodes. Okay, so Oracle will be having root nodes, branch nodes, leaf nodes, like this. Okay, so for scanning only 10 rows, right? So this is the table layer. So this is where the table is there. So all the data will be stored in the blocks in the form of rows, right? So for scanning 10 table, what Oracle needs to do? Oracle needs to traverse through the index branches and the nodes. So once Oracle fetches that particular block, the index entry, it will just go for checking the row ID from the table, so where the actual data is stored, to find the address of the block. Again, once it finds the row ID from the table, it needs to give the results to the end user. So here there are you can take it as two different IO. Okay, one is index IO, another one is it needs to scan the table. So you cannot take it as two IO, but it has to do two different operations, right? So end of the day, IO is just a collective task. Okay, so we cannot count the IO, but there are two different tasks. One is traversing to the index, and next one is going to the table and fetching the blocks. And if the data is completely stored on the index, then that is different case, but I don't want to confuse you. So here there are two different cases, right? So when it comes to small table, I would say the table itself small, only 10 rows are there. So you are going to completely scan the whole table. So here, instead of using the index, what you can do, you can directly go and fetch, you can scan the whole table, right? Instead of going to the index and fetching the data from the table. But if there are millions of rows, right? So then using the index will outweigh the benefits. I mean, not using the index will outweigh the benefits. So which means, like, if these many rows are scanned from the table, then that will become a huge cost. So better we can directly go and traverse the index and use the index. So using an index will be beneficial here when we are scanning minority of the data from majority of the rows from the table. Okay, so here hash join and table access full, these are not the expected plan. Okay, so but still Oracle is able to estimate the rows properly. So estimated rows are 13 and actual rows are 13. Okay, so here if you see almost 13 rows needs to be selected. Okay, so what I will do is, I will just delete the orders statistics. Okay, again let me run the query without the hint. So when I just delete the statistics, now if you see, Oracle is going for some other plan. Okay, so when statistics are not there for a table, Oracle will by default use the dynamic sampling. Okay, and it may have some adaptive mechanisms which will choose the execution plan during the runtime. It may change the plan during the runtime. So now optimizer has chosen a different plan. Okay, so yeah, now we need to set the statistics level to all. And now yeah, we need to again check the runtime execution plan. So now if you see, when I deleted the statistics for that orders table, here you can just observe these two columns, okay, estimated rows and actual rows. So estimated rows are 41, and here estimated rows are 41, here also estimated rows are 41, but this is specifically for orders table, okay, these three rows. But for customers table, if you see, estimated rows are 1000 and actual rows are also 1000. Okay, so E rows means estimated rows, A rows means actual rows. So E rows are just, it is kind of a prediction, or we can say estimation by the optimizer before the query gets executed. Actual rows are the actual data that is selected, which means once the optimizer prepare the plan and the data is fetched, and when you get the result, right, so that is the actual execution. But this is just an estimated. Before the execution, optimizer will do some calculation and it will just try to estimate what can be the best plan, right? So optimizer has to depend on the statistics here. Okay, but since I deleted the statistics, optimizer has no other help, right? So it has to do some math by itself. But always when statistics are not there, then optimizer will be helpless. That's it. So that's where you see this mismatch. So estimated rows are 41, but here actual rows are 13. Here also 13. Here 41, but here 5000. So imagine in real time, if multiple queries are having these kind of issues, then imagine how big the performance issue will be. Okay, so having good and up-to-date statistics are very important for any query. So also having a good histogram is also very important when there are skewed data. So if you go to a real world situation, obviously majority of the data will be skewed. Okay, we cannot say that every table will be having a uniform distribution. So obviously this is where all the performance issues arise. Okay, this is why a lot of performance engineers are required, okay, compared to other administrative activities. Okay, so here we need to correct we need to tell the optimizer saying that you are not if there is a mismatch here, then this is the issue. So we found the root cause, right? So what we need to do is we need to use the SQL profile and tell to the optimizer saying that you are using the wrong plan. So I'm just giving you some hint via some SQL profile tool. So if you are able to use that hint, then you can get out of the confusion, and you can also refer the so it is kind of choice questions, right? So if you are going for any exam, right, so there will be multiple choice questions, and they will be giving some hint in a few questions to understand. when the question is completely alien, right? So likewise, we are just giving the hints with the choice. So it's up to optimizer to use the SQL profile. Okay, it's not like that, but optimizer will choose the profile if it is given some guidance. Okay, so even after we use the even after we create a SQL profile, and still if optimizer is not choosing the good plan of the SQL profile, then there is some issue, there is some problem or struggle with the optimizer that we need to identify. Okay, so that is the next more advanced case. So now let us just focus on creating SQL profile. Okay, so here there is no good or bad plan. Okay, end of the day, it's up to the time taken for the query to execute, right? So that is very important. It's not about choosing the right or wrong plan. So even if you are choosing the right plan, and if still the query is taking a long time, then there is no use. But even if you are using bad plan and you are getting the fast output, then the end of the day result matters, right? So no matter whatever we do technically in the back end, it depends on the output. Okay, so let us just continue this in the next video. Okay, so until that, just stay tuned. Thanks for watching.